afternoon, boys and girls, mothers and fathers, sisters and brothers, teachers and students, rich people and hobos, humanitarians and convicts, dogs and cats, aunts and uncles, grandmothers and grandfathers, great-grandmothers and great-grandfathers, cousins and people. My name is Holland Dannenberg, and physics is my business. A very specific business of today is the art of skateboarding. There are many concepts and properties of physics that can be applied to skateboarding.
The entire purpose of a skateboard revolves around its ability to roll. In order for a skateboarder to roll, they must first push off the ground with enough force to overcome friction. When the foot pushes off the ground, there are many forces acting upon the skateboarder. There is a normal force pushing the skateboarder up, and the force of gravity pushing the skateboarder down. Additionally, Newton's third law also comes into play. Newton's third law states that for every action there is an equal and opposite reaction. Thusly, when the foot pushes off the ground, there is an equal and opposite force that pushes the skateboarder forward. In addition, the physics concept of friction and static electricity can also be applied. Skateboards contain ball bearings, which are vital to its ability to roll. Friction exists in each ball bearing. Additionally, when the wheel rolls on the ground, there is an exchange of electrons between the wheels and the ground. Also, when the skateboarder is moving, he has momentum as defined by the equation P equals mv, which states that momentum of the skateboarder is equal to his mass times his velocity.
The ollie is the most basic of skateboarding tricks. It is used by skaters to jump over obstacles and to go onto higher platforms such as curbs or rails. The properties of physics that can be applied to an ollie can also be applied any time a skateboarder is in the air. When a skateboarder is in the air, the concepts of gravity and projectile motion can be applied. To determine how far the skateboarder will fly before landing, you must know the angle of the ramp and the skateboarder's velocity at the top of the ramp. By using trigonometry, you can determine the skateboarder's velocity in the upward direction. As soon as the skateboarder leaves the ramp, he is accelerating downward at a rate of 9.8 meters per second. Additionally, at the peak of his trajectory, he will be traveling 0 meters per second in the vertical direction. Thus, you have initial velocity, final velocity, and acceleration. By utilizing the equation Vf equals Vi plus At, you can determine time. Going back, you can again use trigonometry to find the skateboarder's horizontal velocity and multiply this velocity by the time to determine the distance the skateboarder will travel. When the skateboarder lands, he will bend his knees. The bending of knees elongates the time the force is enacting, thus the force is reduced. Another maneuver a skateboarder can perform is a grind or a slide. A grind or a slide is when the skateboarder grinds or slides the trucks or the deck along a rail or a ledge. This grinding or sliding produces friction. The frictional force can be determined by multiplying the normal force by the coefficient of friction. Reducing this force of friction means a skater can grind further. Thus, skateboarders usually wax the ledge or the rail to lower the coefficient of friction. As a result of this friction, a minute sum of energy is transferred into thermal energy. Because two surfaces are in contact and rubbing against each other, there is an exchange of electrons and static electricity can result. However, because the rail or ledge is grounded to earth, a shock usually does not occur.
An inevitable part of skateboarding is falling. It hurts. The force of the skateboarder hitting the ground can be determined by the equation force equals mass times acceleration.